Hey, Phil Mitchell again. I just wanted to go over. This has to do with, I guess, my estimating program or just estimating uh, cost engineering in general. With 20 years of experience, I've encountered this multiple times in multiple different scopes of work, scopes of services, different work breakdown structures, and all that. This just happens to be one I did for the plasma cutting tables and then welding times. Um, Something that took quite a bit of time to research myself. But this is how I guess operate. This is how I produce. You know, my estimating program. It wasn't just based off of rules of thumb and guesses. So you research actual data uh, from from this is the plasma table. So from I think this is from Lincoln, um, the Lincoln tables. I don't know. I had a couple, but so if you compile all their information, look at some known possible values, and then plug in maybe some lower rates or even faster than like what they're stating. Um, Over here, then you run different scenarios for different thicknesses of a plate, different size. Um, Maybe put some holes in there and just other different variations of what you're going to be cutting. And then you get here's basically the process. uh so you get your stock sheet to the burn table. That's removing the scrap and the drop from the table. Here's your plasma cut time, again based on the chart over here. um okay, so this would be the after before and after, I guess, the plasma cut times, programming, loading, you know. So anyway, I don't want to go into too much detail with this. I was just wanted to quick show you that the way I operate and the way I research things and learn more about them. But if you're in tune with your shop, or if you're in tune with your company, and you're tracking your costs, and you're tracking how long things do actually take, then you can benchmark that and verify that from your data tables. Same thing with weld times. Again, I'm not going to go into too much detail because it would take too long. But you have your different types of welds. You have this is a volume of welding based on the criteria. And then here's where the general uh, some known these are definitely known values, but this is the backup data for your production times for welding, for these type of welds. And then this is just the backup information for. Then you compile that information, you put it in your program. So what's generally you'll see a just randomly doing stuff here. But let's say there's a 12-foot beam, and you have a pour stop that's welded to that, usually 3/8. Now, in this program that I made, whenever there's plate and a plate item, it automatically puts in fit up and welding time. So this is cut, burning, and then fit up and welding. And I'm going to zip loose so we can see how the welding times work. So up welding. Now here's all your different variations of your possible welds. I'm going to do a couple different options just so you can see how it works. But the 3/8 plate, I'm going to use the 3/8 fillet just for this video. It's 12 foot long and there's one piece. So this is basically a continuous weld. We got 2 hours of welding. If if I chose this as being fit up and welded, yeah, it comes to I guess it comes out an hour and a half. I'll just go back to ship loose. Now that's a fillet. If I would choose a continuous, so let's just do one pass. Now it comes in an hour at 3/8. But not all welds are continuous. Some of them are different requirements. So this is like a 6 and 12. Good. Yeah, 6 and 12 is you see that a lot. So you can see how it obviously it adjusts for the shop welding time. Um, and this is just looking at one piece. So obviously in a whole takeoff where you have a 500-ton job and there's various welding required, it will help you to compile that information based on, again, some relative, some known values, some historical data, and if you're tracking your costs and you're doing time studies in your shop, you'll know that these are correct or not. Also, you have same thing with the field. So now you have field welding. The way I made it is that so that the field is it takes twice as long in the field than it does the shop. But where I was previously, they talked in field time in man days, man days. And another issue with welding is the guy standing, and the weld is at a relatively at shoulder height, to waist height, or is it overhead? Vertical is double. It should double that. Yep, double. Or if it's overhead, it's even like quadruple or something. Yeah, 2 hours, or two man days. So same thing with in the shop. If it's a difficult weld, depending on the situation, now we adjust for the man hours appropriately. So anyway, just wanted to quick show you that too.